Hello and welcome to The Explainer. If you're building a house, you already know the pressure is on. You want your dream home to stand strong, to last a lifetime, right? But then you're standing there staring at endless bags of materials, drowning in technical jargon, and it's just incredibly easy to feel a huge wave of anxiety. Picking the right cement can literally feel like a monumental task. Well, today we're going to remove that stress entirely. We are walking through the top 10 things you absolutely must keep in mind when selecting cement, breaking all that heavy science down into a simple, straightforward explainer. Let's get into it.
So, we all want the absolute best for our homes, naturally. And human instinct tells us that best has to mean buying the absolute strongest, fastest hardening cement available on the market. Makes sense, right? But I want to throw a question out there that really challenges this common assumption. Is buying the highest grade or the fastest hardening cement really the superior choice for your living room walls?
Well, the crucial point is that assumption is actually a massive myth. Adding extra cement or opting for high early strength grades can absolutely backfire. As our source material highlights, high early strength concrete is highly prone to cracking. So if long-term service life is your actual goal, chasing a massive early strength number can actually lead to unwanted long-term structural flaws in your house. Definitely not what you want.
Okay, so to help you navigate this whole landscape, we've organized our top 10 things to keep in mind into these 5 critical phases. First, the selection myth. Second, grades and types demystified. Third, matching environment to cement. Fourth, quality, testing, and storage. And finally, mix, water, and durability. Let's dive in.
Section 1. The selection myth. Faster isn't always better.
So the very first crucial point on our checklist is understanding these grades. If you look at the 28-day compressive strength of 33, 43, and 53 grade ordinary Portland cement, or OPC, you'll see the 53 grade reaches a higher strength much faster. But, here's the catch. The intense heat it generates during this rapid hydration requires extremely careful curing on the construction site. If your contractor doesn't manage that heat perfectly, your concrete is going to suffer from internal volume changes and long-term structural flaws. Faster isn't always better if it's not managed properly. Moving to our second consideration, this means looking beyond standard OPC. Let's compare ordinary Portland cement with Portland Pozzolana cement, or PPC. PPC is absolutely brilliant for standard home construction because it produces much less heat of hydration. But more importantly, because of its chemical makeup, it offers significantly better long-term resistance to environmental attacks like sulfates and chlorides. So for a lot of homeowners, a blended cement like PPC is actually the smarter, much safer choice over a high-grade OPC.
Section 2. Grades and types demystified. Understanding the chemistry.
And this brings us to points 3 and 4, the chemical compounds. Don't worry, we aren't going to turn this into a high school chemistry pop quiz. But cement isn't just a basic gray powder. It's a very specific mix of compounds, primarily tricalcium silicate, let's call it C3S, and dicalcium silicate, or C2S. Point 3 to remember is that C3S is your fast-acting strength builder. It gives you high early strength, but man, it generates a ton of heat. Then point 4 is C2S, the slow-acting compound. It takes its sweet time hardening, which means less heat, and it's actually the compound that provides your concrete with its vital long-term chemical resistance. So why do we care so much about this heat? Well, because the chemistry of concrete is literally a thermal reaction. The heat released during hydration actually causes an internal volume change. If your cement has too much of that fast-acting C3S, the rapid heat generation can literally pull the concrete apart from the inside as it cools and shrinks. It's a really delicate balancing act. Section 3. Matching environment to cement. Preparing for the elements. Point number 5 focuses on exposure. The IS 456 code forces us to match our cement to specific environmental exposure conditions, ranging from mild all the way up to extreme. You just cannot use the same mix for a dry, inland home as you would for a coastal property. If you're building near the ocean, your concrete is facing severe or very severe conditions. You literally have to select a cement type and a mix design equipped to handle that specific hostile environment. And if you don't match the environment properly, you run into point number 6, environmental attacks. The terrifying reality is what happens when carbonation and chloride attacks occur. Using the wrong cement in a harsh environment allows moisture, oxygen, and chlorides to penetrate right in. They literally eat away the protective alkaline layer that surrounds your steel reinforcement. And once that steel starts rusting and expanding inside your pillars, your entire structure is in serious jeopardy.
Section 4. Quality, testing, and storage.
Verifying the specs.
Points 7 and 8 revolve around these essential factory tests. Point 7 is fineness. Now, finer cement gains strength quickly, but it is incredibly susceptible to what's called air setting. That means it can deteriorate just sitting in storage by absorbing atmospheric moisture. Then point 8 covers soundness and compressive strength. Soundness basically ensures the cement won't abnormally expand after it sets, and compressive strength verifies it actually meets the baseline structural requirements. Never, ever skip verifying these lab results.
Now, what's really interesting is this specific number, 90 minutes. This represents a ticking clock, specifically the initial setting time required for certain high-strength cements, like the 43 grade that was originally designed for railway sleepers. It really emphasizes the urgent window your contractors have. Once that cement mixes with water, the chemical reaction begins immediately. They have a very finite period to pour and compact perfectly before the concrete begins to lose its plasticity.
Section 5. Mix, water, and durability. Execution on the construction site.
Let's look at point number 9, which is really about understanding the tragedy of poor concrete. We can basically track the exact life cycle of failure here. It almost always starts with high permeability, meaning the concrete is too porous. This acts like an open gateway for moisture and chemicals, which leads directly to step 2, internal volume changes. Finally, that volume change creates microscopic cracks, which inevitably leads to fatal structural deterioration. Keeping your concrete impermeable is absolutely your ultimate defense. As this wonderful quote from our source material puts it, concrete is a very loyal and dependable construction material. It should not be abused to the limit. It should be used with understanding, love, and care. I just think that brings all our points together beautifully. Durability isn't just about chasing some impressive 28-day strength number on a lab report. It is about long-term survival against the elements, careful handling, and treating the material with the understanding and care it actually requires.
Which leads us to our final point, number 10. And wow, it's a massive one. You can meticulously select the absolute perfect cement, match it brilliantly to your environment, and it can all be ruined in seconds on site. The water-to-cement ratio is the ultimate deciding factor for durability. If your contractor lazily adds too much water just to make the pouring process easier, it'll instantly increase permeability and destroy everything we've just built. So are you keeping a close eye on the water bucket at your site? Think about that as you take your next steps in your construction journey. Thanks for joining us on this explainer, and we'll see you next time.